Okay, welcome back. In this segment, we're going to basically talk about the title of it is Why Homes Act Like Chimneys. The idea being, and I mentioned this earlier, radon doesn't have an evil mind. It's not necessarily even an evil chemical. I think it's fair to say there's no such thing as a chemical that is by its nature good nor evil. It's just a chemical. And so the question then is, how does a chemical, in this case radon being a gas, how does it go from where it starts into the house? And the answer to that is homes act like chimneys. And the idea being that, the home is under the same pressure naturally as the outdoors. And so there really is no reason for radon to migrate into the house. And then things start to change. You've got a furnace that has a vent that goes to the outside. You've got a water heater that vents air to the outside. You've got a fireplace that has a vent that goes to the outside. These are all pulling air from the house and venting it to the exterior, which causes a vacuum inside the house. The dryer is the same thing, a clothes dryer. It's going to pull air from the inside of the house and it's going to vent that to the exterior. Now you've got this vacuum and the house is saying, hey, I need replacement air from somewhere, and it's going to take it from wherever it can. It's going to take it from around the doors and windows, of course. We've all felt that cold draft in the winter, but maybe you live in a nicer home that has tighter doors and tighter windows. And, then the house is saying, hey, I got to have replacement air. And the next thing that happens is we're drawing actually air from around the foundation and the slab that's coming in from the soil, and that's how this radon finds its way into the house. Radon is heavier than air, so it's going to stay primarily in the basement, and that's why EPA's assumptions were that the person is living in the basement at that higher rate. So you have the house basically trying to draw air from wherever it can get it. If it can get it from around the foundation, if it can get it from around the doors and windows, it's going to get it from wherever it can. And so this process actually draws the soil gases that are outside the house into the house, and that's how you pick up a radon concentration that is greater than outdoor or background concentrations. So that's how it is drawn in. Now the next question is, what factors are going to contribute to a higher radon concentration? Because we all know that there are some homes that just have lower concentrations and they will never in their entire existence have elevated radon concentrations that are as high as other locations. So let's answer that. If you live in an area that is higher in minerals, for example, especially granite will often have higher levels of radon because you're starting with some uranium and radium that just tend to come naturally in granite. You have heard, I think, the concern that a lot of people have about having granite countertops because they're concerned that the radon might be originating there inside that granite countertop and getting into the house. The answer to that is that that's much less of a problem because that granite is sealed, and the radon, like I say, has a 3-day half-life, and if it can't get through that seal, it's not going to get into the breathable air, and it will further decompose within that 3 days, and then you don't have a problem. But granite. So if you have, now imagine yourself being a geologist for a minute. You're going to have maybe the mountains over there, and that of course is going to have large rock. It's going to have, as you move away from the mountain, you're going to have more of a gravel, then you're going to have a sand, then you're going to have a silt, and as you get closer towards maybe a lake, you're going to have groundwater. Now you have much different potential risk levels as you go from that different sort of geology. For example, let's say that I was a radon particle and I was up near the mountains and I wanted to get into the house. It's much easier to move from what's called the point of origin into the house if I only have to move through these large boulders in order to get into the house. It's still relatively easy if I have to move through maybe 1-inch diameter rock or gravel or even sand and get into the house. That's still doable if I, the radon particle, want to get into that house. By contrast, let's say that you've got maybe a silt, which is a finer material, or even a clay, which is a much finer material, or let's say that a clay that is submerged by water. So in those sorts of circumstances, you're going to have, it is much less for me, the radon particle, to move from my point of origin into the house, because clay is tight. There's not a lot of air spaces, and there's not really an easy pathway for me to move through that clay into the house. And perhaps by the time I do so, my 3 days is going to be up and I won't make it into the house, and we don't have that risk. Now, I should mention again, half-life means that half of the material has decomposed by then. It's entirely possible that the radon particle that you might pick might last for 6 days or 7 days or 12 days or whatever that number is, but there's going to be much less of it that gets into the house the more difficult it is. And then, of course, if you've got actually a groundwater in beneath the house, it's going to have a very difficult time, and you basically shouldn't have a problem. Maybe you're gonna have to bring a radon rock, or not a radon rock, a uranium rock into the crawl space so that you can have the radon in those sorts of circumstances. And I jest, of course, but that's the kind of thing you want to look for. Now, especially if you've got a home, and I actually had a realtor summarize it this way. He basically says radon follows money. And that's kind of true, because you're going to have the nicer homes that are up in the foothills. They're going to be in the, I want to say the canyon washouts and the riverbeds, that sort of place. And in many cases, that's where your money is going to be. Riverbeds can be a problem because you're getting those minerals and the granite that has washed out from the mountain, and you've got that larger soil, a larger rock in the soil. And so as a result, it's much easier to have a radon problem there in the riverbed sorts of environments. Sand, gravel, silts, clays, we talked about that. Hills, lakes, and groundwater, rivers and river rock. If you've got that, you have the geologic factors that can cause a potentially higher radon risk. And it's in those areas where your home inspector should be more carefully considering whether he should recommend a radon test. Next section, we're going to talk about radon risk rates, and we're going to move on after that and talk about the risk increasers and decreasers, and we will be right back.